So, some basic background information. On August 9th, this report and order was released by the FCC regarding Part 101 bands. And this has been a long time coming. The proceedings actually been going on for about 2 or 3 years. And it addresses opening up additional spectrum for microwave backhaul use. It also addresses the addition of new technologies like the legalization of adaptive modulation. And it raises additional questions and concerns about other factors that they're debating, such as smaller antenna sizes for some of the lower microwave bands and larger channel sizes for more throughput. So before we get into it, I'm just going to run through the agenda. We're going to start with an executive summary of the docket. Afterwards, since this is what's new and exciting in everyone's mind, we're going to talk about 7 and 13 gigahertz, what the rules are, what the operations are, and where one can license it. After that, we'll talk applications, because frequency is one thing, but we want to know what can we do with this band, where can we do it, and what capabilities. And then, since everyone likes to talk real world, we will talk about a microwave solution that is available for this band, what the capabilities are, and talk a little bit about the technical overview of the product. Ample time will be left for Q&A at the end, and we will have periodic breaks within the presentation to answer questions. So as things come up, feel free to ask them as necessary. So first thing, I'm going to assume everyone has a basic understanding based on the questions we asked during registrations of microwave backhaul. But in the event that this is a new topic, there is a band or a subset of the FCC rules called Part 101 that deals with licensed microwave backhaul for common carrier and private network type applications. Essentially, these are licenses done on a site-by-site basis. So rather than having to have an auction or going through a process there is a process for coordination that allows private operators, common carriers, service providers to license a link between 2 fixed sites and utilize spectrum for backhaul purposes. Commonly for Part 101, although there are a lot of Part 101 bands, the most widely used bands are in the 6, 11, 18, and 23 gigahertz bands. Depending on distance and channel sizes and everything, people can shoot 40 to 50 miles and deliver speeds of 300 to 500 to even a gigabit per second of backhaul capacity. What's nice about this band is being a coordinated band. It is licensed on a per-link basis. Generally, engineering fees to do the coordination run between 500 to 800 bucks a link, and then there are FCC site fees. So for an operator or for someone looking to build their own network, for less than $2,000 all in, one can have their own licensed microwave backhaul link. That's why it's extremely popular. So the introduction to this. Essentially, with everyone understands broadband is important, and with the National Broadband Plan, there has been a push towards how do we get more broadband, or how do we enable broadband in more rural or underserved markets. In many of these markets, microwave has traditionally been the way to do things rather than using antiquated copper or building out new fiber infrastructure. So in this report in order, the big headline is the FCC has made as much as 650 megahertz of new spectrum available, primarily in rural areas for wireless Part 101 backhaul applications. Let's go through the specifics of the report in order. This is a 100-plus page document with hundreds and hundreds of pages of supporting documentation and footnotes. So what we've done is read the whole thing, and we're going to give you the high points. The two highlights of how it pertains to private service providers is it has allowed for adaptive modulation. I assume most people here will know what adaptive modulation, but they've created additional leniency in the adaptive modulation rules, which will allow for better and more appropriate link budgets, which we will discuss further. The other big point on this rule report and order is it allows for Part 101 operations in the 7 gig, technically 6875 to 7125, and 13 gigahertz band, 12700 to 13100. These are bands currently used by the broadcast and cable people. So it's traditionally for fixed or mobile broadcast auxiliary or cable TV relay services. The main point is that Part 101 operations will be allowed in areas where the band is not currently licensed to TV mobile pickup stations for news gathering and other TV-related broadcast operations. Finally, there's a subset of the rule adopted because the BAS and CARS guys are the incumbents. They've been in the stand for over 20 years. So there are protections in place for those operations so that new entrants on the Part 101 side will not interfere and cause issues there. In addition, in the report and order, there was an NPRM and a notice of inquiry released. The FCC is seeking feedback on allowing smaller antennas in certain Part 101 bands. So traditionally, everyone knows that frequencies under 10 gigahertz are more preferable for longer distance links because of better rain fade and propagation characteristics. But for a lot of people, specifically in the 6 gigahertz band, the 6-foot dish requirement has always been kind of a tough one for people to swallow due to cost, tower loading, and all those sorts of factors. The FCC is seeking comment, and this is something that is debated, so perhaps in the next year or two, changes may occur. Specifically, they want to see if a 3-foot dish would be allowable in the 6 gigahertz band, if a 1-foot dish would be allowable in the 18 gigahertz band, and to see if they can get away with a 8-inch, or actually it's not a 0.75, that's a typo, 2/3 of a foot of a dish would be allowable for the 23 gigahertz band. Additionally, because people have addressed concerns about bandwidth and capacity, specifically in the lower frequencies, when adding in the extra frequency in the 7 and 13 gigahertz band, the FCC is also asking, would it be feasible to allow for larger channels, say 60 megahertz channels for 6 gigahertz and 80 megahertz channels for 11 gigahertz, so that people can deliver higher capacity backhaul links for their network. So let's get into the specifics now that we've hit all the high points of the report and order. So adaptive modulation, why is it nice? Well, adaptive modulation enables your link to stay up. So rather in a situation where your link budget would drop completely from, say, 100 meg to nothing, adaptive modulation might add a few subsets, maybe 75 meg, 50 meg, 25, where the link will continue operation, but at a reduced throughput level. Many people like this because people would rather have a link somewhat working than having a complete all down or hard down type situation. So what the report and order has done is they've enabled a 99.95% standard to meet the minimum capacity or performance levels required as per section 101.141A-3. And as long as the 99.95 standard is maintained at that minimum, it will allow modulation steps modulation steps lower than what the minimum performance thresholds are for that specific band. So translating that into English, for example, 11 gig on a 30 megahertz channel per FCC rules requires a 100 megabit per second minimum payload to go over that 30 megahertz channel. So under the current or the prior rules before this report and order, if you have a link up and a fading condition occurs and your thresholds fall below the 100 megabit per second level, you cannot operate the link at that point and the link would drop. What this says is, as long as the 100 megabit per second level is maintained for 99.95% of the time, which is done at the prior coordination section of the link budget, we will allow the link to drop to maybe 75, 50, or even 25 megabits per second in order to maintain it for the less than 5 hours a year of downtime that a provider or an operator would have on their system. What that translates to, and let's talk about the real-world application. We happen to use our Apex 9 radio just because, as an example, just because we have the data handy. Under the old rules, here we have a 20-mile link and 11 gigahertz with 4-foot dishes. Under the old rules, if I take my pen out, we have to maintain spectral efficiency at about this QAM 32 or higher level. So if you look at it, the minimum threshold here is a receive sensitivity of negative 74.5. So although the radio chipset could modulate lower to, say, QPSK to maintain the link, because of how FCC spectral efficiency rules work, we can't take advantage of this extra 8 or 9 dB under the old rules. So what would happen then is a provider who says, well, negative 74 or 74.5 is my minimum threshold level. I need to potentially use larger dishes, maybe 6-foot dishes, just so I can maintain my link. Now, under the new rules, QPSK, which in this case delivers about 55 meg or so, is allowed because our QAM 32 at 156 or 167 megs satisfies the 99.95% level. You see here we have 99.96. And then, in addition, we can utilize adaptive modulation. So we will be able to enable QPSK on the radio level. So in the event of a deep fade scenario, we can take advantage of this extra 10 dB of fade margin from the receive sensitivity side to give a better link budget. So looking at the microwave world, this allows us, at least for the Apex 9 system, it will add an additional 10 dB of fade margin through the back-off using adaptive modulation. Does anyone have any specific questions to how adaptive modulation relates and the application for this? I've tried to be pretty thorough, but it can be confusing. If you're to step back and look at it from a high-level perspective, if you're dealing with a platform, most manufacturers, essentially with adaptive modulation, it should be able to add anywhere from 5 to 10 dB of additional fade margin for some of your links if you're willing to accept the performance degradation to maintain the link status. Okay, moving on. 7 and 13 gigahertz bands. So the rule and order, or the report and order, allows for Part 101 operations in those bands. However, there are specific rules and variances put in place to protect the incumbent and existing licensees. Specifically, with BAS, there is a fixed version used for point-to-point TV relay backhaul and a mobile type of licensees used for temporary broadcast scenarios. So those are those trucks, the TV trucks that drive around with the mast that can point up and do live broadcast feeds for news. So in areas where there is a previously licensed pickup station, Part 101 operations are not allowed in those bands. That is a good chunk of the metropolitan area. However, there still is a lot of flexibility for availability in more rural and suburban areas for this. Secondly, it requires coordination. So just like how Part 101 does, your frequency coordinator, companies like ourselves or other people if you decide to go elsewhere for that, will have to, in addition to coordinating microwave paths, will have to coordinate in the 7 and 13 gigahertz band against existing TV pickup stations and relay links as appropriate. From a quick high-level summary perspective, 7 gigahertz, they've allowed 5, 8 1/3, 12 1/2, and 25 megahertz channels. And the rules for 7 gigahertz, they're mostly going to be what's in line with 6 gigahertz. So people who know the spectral mass, antenna size, capacity requirements of 6 gigahertz, that will be what it is for 7 gigahertz. 25 megahertz channels are the standard channel size that they're using. And the reason behind doing that rather than the 30 meg channel, which is used for 6 gigahertz, is due to the existing band plan for BAS and cars, which utilizes a 25 megahertz channel. For 13 gigahertz, it is the rules from an operational perspective are similar in line with 11 gigahertz. So the smaller dishes are usable. And because of the greater amount of spectrum available for 13 gigahertz, they've also allowed for 50 megahertz channels so people can deliver more bandwidth and throughput over their existing microwave links. So let's look at real-world specifications in terms of what you can get on the band with radios. Again, we're using our Apex 9 products just because it's something we know intimately. But other specs are maybe similar. So depending on your dish size, combining the new band with adaptive modulation, if one uses a 6-foot dish in 7 gigahertz, one will be able to deliver a distance of 30 miles, about 180 megs of full duplex throughput, while maintaining 5 nines of availability. Now, one thing keep in mind, we are taking the full adaptive modulation for availability. So the 5 nines is running at a 44 meg full duplex rate for availability, which is the lowest level of QPSK to maximize the link budget. With 13 gig, depending on dish size, from 6 to 4 to 3, because of the larger channel size, one can deliver 350 meg and do distances of 18 to 8 miles, depending on the appropriate dish sizes and everything. Obviously, 13 gigahertz doesn't have the same propagation characteristics as 7 gigahertz. It also has rain fade to worry about, but 13 gigahertz has the benefit of smaller dishes due to the rules and the ability to deliver more throughput. So this gives you guys an example or a sample size of what is available. Obviously, if you have specific questions, you can always feel free to contact us directly, and we'd be more than willing to help you with design for your path. Now, here's the big thing, exclusion zones. Where is it allowed and where is it not allowed? Now, this is a rough guesstimate of the exclusion zones. It is actually a little more specific because if you look back at the rules, the exclusion zones, A, only apply if the area is licensed for a specific channel, and B, the distances around the zone for purposes of simplicity and to get a nationwide map, and because it was just a lot of work, we use the standard size of 90 kilometers for radius around the central license point. Each specific license has a different radius. Some are as little as 50 or 60. some are as large as 100 to 150 kilometers. It is license specific, and what we would end up doing is, at the frequency study perspective, is when we would actually analyze it and see the interferers. But for purposes of simplicity, we just use the 90-kilometer radius because that is the average if you average out all the licenses. So this is 7 gigahertz. Obviously, the green areas are all the excluded areas. So in these green areas, you will not be able to, or licensing of 7 gigahertz would be subject to a variety of restrictions. In the yellow areas, you will have no problem. So what does that mean? Does that mean you cannot license 7 gigahertz in the green area? That answer is no. What it does mean is it's going to be more work for your frequency coordinator to license 7 gigahertz in a particular green area. Let's move on. For 13 gigahertz, obviously the coverage of 13 gigahertz is not as prevalent as 7 gigahertz. So you'll see that on the yellow perspective, there is more availability. Again, green are the exclusion zones, but these are not meaning you can't do it. These just mean that the licensing of 13 gigahertz is suspect to more interference and more coordination than what would be in the yellow zone. And you would have, your frequency coordinator would have to do very detailed work to figure out if it is possible or not. There was a question. I think I will address it now. How will fixed microwave entrants deal with the existing stations that are either missing their coordinates, missing their dish height, or don't have information? This is something that is still in the works. You know, we're involved along with ComSearch and Micronet with the National Spectrum Managers Association. As the databases have to be coordinated, we are making everyone's making outreach on our side over to the broadcast guys to see if some level of cooperation or information exchange can be made, because the questionnaires point that there is a good percentage, or there is a percentage of fixed stations on the TV side that are not registered or licensed. That is an issue that hopefully will be addressed shortly in the months to come. Let's just kind of zero in a little bit. This is the state of Minnesota, and what we're doing here is we're comparing the use of 7 gigahertz in the BAS system against 6 gigahertz common carrier. So as you see, there's a lot of 6 gigahertz that has been deployed. You can see it all circled in here. And even if you take out, you know, the worst case exclusion zones for the BAS region, you know, say I color these all green, and you know, one can't deploy. I guess I'll just throw this right here and throw this here. So this goes away. This goes away. And then we kill this right here in this corner. And then let me change the color to make it a little better. You know, you see this highlighted yellow region. You know, this highlighted yellow region represents areas where 7 gigahertz coordination should not be much of a problem, just because of availability of spectrum, and there aren't any of the pickup licenses there. These green circles, if I go back to my other tool, these green circles represent areas where there are TV pickup licenses. Would coordination be possible in here? There is a chance, because, again, for purposes of our exercise, we just used a simple 90-kilometer radius for these. So some licenses might only be 50 kilometers. Some may actually be larger. And then there's another subset of rules. So these green areas are places where there would be work to be done if you were looking to, or not work to be done, there would be more work to be done for licensing 7 gigahertz versus in the yellow region. This is 13 gigahertz. So comparing 13 gigahertz against 11 gigahertz, obviously, as compared to the 6 gigahertz, you don't have the long-haul networks in place because 11 gigahertz doesn't have the propagation characteristics that the lower frequency has. But you'll also notice that there is a lot more availability. So in the surrounding areas out of the major metros, there's plenty of availability for 13 gigahertz for backhaul. And with the 50 megahertz channel, that makes it really exciting because that's higher capacity than what's available today for 11 gigahertz, which is limited to a 40 megahertz channel. And that's that. Take a look. This is Nevada. If you're in Nevada, there's not much to worry about, so you can deploy 7 gigahertz till your heart's content. And actually, it looks like there is no licensee in Las Vegas. So this is a major metro that our maps show is readily available for 7 gigahertz licensing. Here's 13 gigahertz for Nevada. Obviously, there's some little 13 gigahertz, but if you look into Elko, 13 gigahertz is available. So again, this is just kind of the overview of how what the availability is for some of these places. Okay, moving on. We've kind of gone through the rules and everything, all the changes, and now let's talk about application. You know, what are you going to do, or what can you do to take advantage of these new rules? We're going to be a little biased, obviously, because this is our product, but you know, your challenges in backhaul, there are solutions. From our perspective, you know, our solution bundles in the frequency licensing side of things, delivers a 350 megabit per second full duplex radio, gives you the benefit of licensed spectrum, and is a solution that is, from our understanding, one of the most cost-effective licensed backhaul platform on the market today. So ultimately, will help save you money. Where did my thing go? Highlights of the platform, you know, very reliable, scales quite well, and we believe it offers a great ROI with the lowest total cost of ownership to deliver a 350 megabit full duplex microwave solution. What are the benefits? The solution, you know, our organization, we are probably the only organization that has the microwave side and is recognized by the FCC as a direct Part 101 coordinator. So when working with us on this, you know, you guys can be aware that you're working with the source and not working through a middleman who is using someone else like a Micronet or a ComSearch for their coordination services. You know, a little bit about the backhaul platform. This is an actual picture of the radio. It is today an IDU, ODU type scenario. So you've got a half rack unit mount IDU. It is possible to also aggregate this link, and the reason why we did a half rack unit is we have a fixture to allow for 2 of them for a full rack, and then putting 2 of the outdoor units on the back of the antenna. So summarizing things, it is a 350 meg single radio full duplex solution at 256 QAM at the max channel size. The way this backhaul is packaged, we thought it was too complicated to deal with things like license keys and pay-as-you-grow type things. So we have packaged it with full bandwidth out of the box. So if the solution is offered, it comes in the full capacity. It is a very high power solution. So depending on the frequency and the FCC rules, the radios will actually come out of the box with up to plus 30 dBm of power at the ODU. We allow for aggregation for capacity doubling. So there's what's called a dual radio head mount for the antenna. So one can do 700 megabits per second full duplex through a single antenna by running two of these simultaneously. And we offer it with very good latency. Standard latency is around a little less than a third of a millisecond round trip. And we have a mode that has been used on the financial services side that knocks the latency down to about less than a tenth of a millisecond round trip. Bandwidth options. This doesn't include the new 7 and 13 gigahertz stuff, but on a 6 gigahertz link, this platform can deliver up to 200 meg full duplex on a single channel. At 11 gig, you can do about 260 meg on a single channel. And with 18 and 23, if you're running a 50 meg channel, one can deliver up to 350 meg of throughput on a single channel. Why do we think it's exciting? First is very high capacity, up to 350 meg full duplex per channel, or 700 meg if you want to bond them. It is one of the most cost-effective platforms out there. We find the pricing of the Apex 9 to be extremely competitive. Being an IDU-ODU type solution, there is a lot of cabling flexibility. So the distance between the IDU and the ODU can be up to 2,000 feet. And there is no extra tax for high power. Again, just like how the bandwidth comes out of the box maxed out, we deliver these radios out of the box maxed out on power, so anywhere from 25 to plus 30 dBm, depending on the frequency band selected for the radio. Advantages, here's all, the laundry list of all these great things, 6, 11, 18, 23. We actually are in the process, probably by the middle of this month, we will have 7 and 13 gigahertz support all done. We're just finalizing interop, anywhere from 10 to 50 megahertz channel bandwidth. Again, we have the ability now to support QPSK modulation. So with the new adaptive modulation rules, that gives us an additional 10 dB phase margin over another platform that might still be limited at the 32 QAM level for the 6 and 11 gig band. Extremely high power, good performance, extremely small on the IDU side, very good ODUs, and a variety of other nice features like APPC and adaptive modulation, which can be configured on a user basis, great diagnostics, and very good management and operational characteristics on the platform. Here are some specifications of our other bands of what's available and what you can get. So, this kind of gives you a quick overview. At 18 gig, you can get up to 350 meg. At 11 gig, you get up to about 260, 270, and at 6 gig, you get up to about 213, based on our over-the-air bandwidth rate. Getting on the tech side, these are some latency testing that has been performed on the platform. So you can see, depending on packet size, the latency stays pretty solid, generally under a third of a millisecond round trip time. Throughput-wise, we utilize compression to get a little more juice out, just like many of the other manufacturers out there. So depending on packet sizes and everything like that, the compression rates go anywhere from 390 meg to, with very large packets, at about 310 meg, because there's just no way to compress those sorts of packet headers. Some frequently asked questions that we always like to bring up. First question, is Apex 9 a new product? I haven't heard about it since a couple months ago. Will it work? Yada, yada, yada. What's interesting about the microwave world is that everyone all uses very similar things. So while we can't specifically go out and name the specific components we're using, if you look at our platform, you'll find that the ODU we use is made by an ODU manufacturer that has about 90% of the market. And our ODU is very similar to ODUs used by other manufacturers. And in fact, there are some manufacturers that will take that ODU and put it in an outdoor box to call it an all-outdoor radio. From the chipset perspective, people then say, what about the IDU? What about the software? What about things like that? Turns out that the IDU chipset is a very similar world to the ODU world, where there is another manufacturer that makes an IDU chipset that is used by about 88% of the microwave market. And we have adopted that the same chipset and use a lot of the same features that they have. And what we've done is we've put it in a different box and put a blue label on it to make it look a little different from the competitors. So with all that, the platform is based on tried and true microwave chipsets and RF components that have been deployed in hundreds of thousands of microwave systems today. Many of you with existing microwave backhaul networks, the components in your existing backhaul networks are very similar to the components in these radios. Because of the large and extensive reuse of existing technology, generally we feel that there is no new product risk to be worried about with the Apex 9 platform. Second question, what about special antennas? I guess the secret's out. There is an ODU antenna flange that is common to many manufacturers. We use the same ODU antenna flange that many others do. So if it's compatible with the REMIC ODU antenna flange, ours will generally work in that one. Next question, what type of cables do you need for initial offering? We're just using standard 50 ohm coaxial cable. So that could be LMR 400. And depending on the cable type and distance between the IDU and the ODU, this can be up to 2,000 feet. How to order these links? We wanted to keep the price down, and one of the things required in keeping the price down is to make things simple. So what we did is there are no bandwidth keys. Everything comes full bandwidth. There are no power uppages or outages. Everything comes full power. So all you do is order a link from us. It's all about the same. You pick the band. With the integrated licensing that we can offer with the radio, it makes it even easier, so you don't even have to go to a third party for coordination. In addition to a link, there is an install kit that we generally recommend people to get, which includes basic jumper cables, power supplies, and lightning arresters that will make the link work. And then the final thing is if you have antennas that conform with the standard REMIC broadband ODU, we can work with those. If you don't, we can just tell us what size antennas, and we'll make sure you have the appropriate antennas for your link. And you order the link, you kind of sit back, kick it, things just work, and that's that. Okay, I'm going to open it up for questions. I have a few other questions. Let me read the first one, and this is a clarification. It states that I stated that POFS entrants would not be precluded if they are inside the operational area of a TV pickup station. Rather, it triggers additional frequency coordination issues. I do not think this is correct. For paragraph 16 and 23 of the report and order, it is a preclusion because neither the POFS transmit or the receive or any portion of the path can be inside a co-channel TV pickup station's operational area of record. As you noted, though, this still leaves large rural areas that are outside the operational areas of all TV pickup stations. Newcomer fixed wireless or Part 101 links that can frequency coordinate with existing TV, BAS, STL, and ICR links in these areas should be fine. So the answer, this is a clarification, and is something that is, to clarify, what I stated wasn't that you could coordinate inside a TV pickup station license. Rather, what I stated was, for purposes of our exercise, we guesstimated a 90-kilometer circle around the TV pickup station license. So what I said was, within that circle, which was a 90-kilometer circle, which is actually an estimate based on a weighted average of all TV pickup licenses, there is the possibility that there is some availability of either 7 or 13 gigahertz in those circles, but ultimately one has to do detailed analysis to see. And if one is in the ring of an existing licensee, obviously that is not acceptable. So that's a clarification, and thank you for bringing that up. Another question, 7 gigahertz Part 74 use in Vegas is very heavily used. My data is incorrect. I can't agree or dispute that claim. Like I said, for purposes of the webinar, we've done a quick initial cursory overview of what is available and what is not available for BAS and CARS use. Additionally, I think another person mentioned that about 10 or 15% of BAS and CARS licensees are not actually registered or licensed in the Universal Licensing System or other FCC databases. So our data was based on what was pulled from the registered database. So if you factor in the extra 10 or 15%, and then factor in the efforts that we need to do to collaborate with either the National Association for Broadcasters or the National Broadcast Engineering Associations and everyone to get things that are just in people's drawers out on an online database, there is some margin of error for the maps that we showed. And again, that's what I said. Those were general guidelines. And ultimately, one has to do, at this point, more detailed frequency analysis to see if a 7 or 13 gigahertz license is available. Okay, the other fellow just clarified a point, and I will just read it for everyone because it's very good information. Basically, it's the actual TVPU operational area that determines the preclusion. Be aware that some TVPU stations have operational areas that are one or more counties or rectangular operational areas. That is, TVPU operational areas can be other than circles. So again, these are things usually that frequency coordinators deal with and handle in terms of the nuts and bolts of the coordination process of what works and what doesn't work, yada, yada, yada. However, it is always good information to know that the specifics of the map, if I actually want to run back to it, let me just do that for everyone's sake. Hold on for a second as the machine loads. if the webinar doesn't load things as quickly. But as I go to, hold on, let me just select slideshow, current slide. So as we look at these circles, just to clarify, please keep in mind that these green circles are approximations for simplicity purposes and just to get things done in a timely manner in time for the webinar. We just plotted a bunch of dots and drew 90-kilometer circles around them just to have a general approximation. The actual reality of how TV pickup licenses are done, some are square, they're not all circles. Some are bigger circles, some are smaller circles, some are squares. You know, your mileage will vary depending on the specific application, and that's where a frequency coordinator, such as ourselves or ComSearch or Micronet, will be able to assist you in that process. So I think we're good for questions right now. At this point, Chuck, are you on the line still?
Well, I am probably on the line. You tell me.
Okay, I can hear you.
Good.
I'd like to maybe, one other thing that I'd like to jump to, and I don't know if you have slides or if you just kind of want to talk about this, is I think one thing that's really exciting for people is this notice of proposed rulemaking. Let me just jump to that slide. For the 6, 18, and 23 gigahertz bands. And to just give everyone an introduction, Chuck is the guy over at Wireless Beehive Manufacturing, which is, really smart antenna guy who started with a variety of antennas that would enhance the performance of a Motorola device. And Chuck is now in the microwave backhaul space. And you currently, Chuck, I think you have an 11 gig and an 18 gigahertz dish available?
We've got, we've increased from, we've got a dish that starts out with 5.8 unlicensed feed horns, so you can install the dish and put on some lower cost radio. And then as you need to grow the link, then you can, the feed horns just pop out from the back, and you can swap them out. We've got 5.8, 11, 18, 23, 24. The 13 is not a problem. We just have to wait till somebody orders one once. We've got 2-footers and 3-footers with 4-footers in the works right now.
Okay, so I guess I'm not sure if you, because of our technical difficulties, we're able to, if you want to share your screen or if you just want to kind of talk about the antennas or what's going on in the Part 101. And, I know a lot of people, when we talked 11 gigahertz, we only talked 3-footer, but there's actually something called a Class B. I mean, do you want to take a few minutes to kind of go through that, Chuck, or do you want me to make you the presenter, or how do you want to?
I can just speak to it real quickly because I know everyone else has a lot of other things they'd probably like to get to. The Category A and Category B is a point of confusion for a lot of people. The FCC has allowed in certain bands for you to use smaller dishes, but it's under Category B usage, so that if you cause someone else interference, you may be forced to upgrade your antenna. It's just kind of a judgment call. If you're out in a rural area, I don't think you're ever going to run into being forced to upgrade, but that's something that you need to be aware of. The Category B antennas are smaller, which in the world of parabolic antennas equates to less gain. It's almost a direct trade-off. Larger diameter aperture collects more energy, you have more gain. Another way of saying that is gain and directivity are the exact same factor. The FCC obviously wants you to not be spewing energy out in any direction other than in a laser beam to the other end of the link. Unfortunately, in the real world, with the antennas that are available, none of them are perfect. None of them are ideal. There's always going to be energy leaking in all directions. So what they've done is they have created a set of it's kind of a graph. It's called the radiation pattern envelope, and it defines how much signal you can leak in all of the different directions. And if you leak less than that, then you can comply with a Category A or a Category B radiation pattern envelope. 11 gig allows, well, if your antenna is really clean, you can get away with a 2-footer. You can get away with one of my 2-footers on 11 gig. Not all antennas have a radiation pattern envelope such that their 2-footer will be clean enough to use for 11 gig. 18 gig, you can use a 2-footer without an issue. There's been some confusion that I've heard about why does the size of the antenna matter to the FCC, especially on 6 and 7 gig. Well, it's just as I described. The size doesn't matter. The directivity matters. How focused it is matters. And that's, in a simple way of specifying things, size and gain and directivity are all basically saying the exact same thing in 3 different ways. It's just the physics involved. Oh, I see Charles has got my website up. There's kind of the overall view of the product, and it's also got a telescopic sight that you can click in the back in the place of the feed horn, and optically aim it. It's a lot of people. I put it on a little demo video here, just a really cheap and dirty one shot with my iPhone, about how side lobe aiming can really throw you off, and you may think you're on the peak, but you're really peaked up on a side lobe. The optical aiming aspect of our product pretty much eliminates that. If you can see the other end of the link, if you can see the hilltop, the building, something to give you an indication that you think you're aimed up. If you've aimed it with the scope, it's going to be aimed with the radio. In our experience, you can't get more signal out of it by tweaking it after optically aiming it. Charles, if you wouldn't mind just going back and then clicking on the feed horn page. Just hit products there and go to antennas. Well, actually, just hit products, and it'll bring up the big long list, hopefully. And down towards the bottom of the big long list, it has feed horns down at the bottom of the optic series right there. And this just shows you what the feed horns look like for the different frequencies. And you just pull them in and pull them out from the back, the same port that you use for the telescope. So I don't know. That's about it. Antennas are fairly simple, and I'll be happy to answer any questions. But I think most of the listeners probably have a pretty clear understanding of all of this.
Great. We have, let's see, a few more questions. Let me go with the first one. The report and order also now allows radio stations to use the 940 and 960 megahertz bands for their links. Previously, only 950, part 74, subpart E could be used. Do we have 940 or 960 megahertz microwave radios? The answer is no, we do not. Sorry. Another question. No, we do not. Let me update this. Other question. Do you think the FCC will ever update its map of congested areas where only Category A antennas are allowed? Part 101 has all sorts of interesting things, especially in some of these more congested metro areas, that is causing all sorts of issues for people, from actual filed licenses to people who are just submitting PCNs to, what might be the term, to squat frequencies and reissue PCN, to basically game the system. That suggestion would be great. We would love it. We'll see. I wouldn't really bet on that. So I will respond to that. Probably not. Okay. Well, with that, we've covered basically everything that we had planned to cover. I'm going to probably, I guess, it doesn't look like there are other people with questions. So if you guys have any questions or anything, let me just wrap things up a bit. If you want to be in touch with us about more questions or anything about either the webinar, to get a copy of this webinar, to talk to someone in our organization, you can go to our website and either email us or hold on, let this thing load. The webinar just seems to slow everything. Oh wait, hold on, wrong website. That's embarrassing. Yeah, don't even know my own website. Jeez. Oh, eStore.cticonnect.com. So feel free to, our website is just www.cticonnect.com, or specifically for the hardware side of the business, you can just go to eStore.cticonnect.com, click on the link, give us a call, or send us an email, and someone would be more than happy to help you out. So with that, I want to thank everyone for spending the hour on this call. Thank you for taking time out of your busy day. Chuck, I want to thank you for giving us a lot of your expertise on the antenna side of things. And with that, hope you guys gained some useful information out of this. Hopefully you guys will find a place for 7 and 13 gigahertz in your network, and stay in touch. So thanks a lot, guys, and talk to you soon. Bye-bye.